All right, so today we're going to talk about simplifying rational expressions. So rational expressions are expressions that are fractions. So rational itself means like like a ratio, so something you could write as a fraction. So to get an idea of what we're doing, let's say I gave you a simple fraction to start off with. We're not going to use an expression yet. I mean, 4 and 6 are expressions, but let's say I give you this and I said simplify. Okay, I would assume the majority of you could tell me the answer is 2/3, right? So remember, the reason it's 2/3, I know you're probably thinking, yeah, they have a common factor of 2. We're dividing top and bottom by 2. That's correct. But we're really rewriting 4 as its prime factors, 2 times 2, and 6 as its prime factors, 2 times 3. You could get those by doing like a factor tree, but these are pretty simple. And you notice that they both were divisible by 2. We're basically canceling out this common factor, and you did that division, and then you knew what was left over. 2/3 would be our answer, right? 2 divided by 2 is 1, and 1 times 2/3 is 2/3. Okay, so that's correct. There's our answer. Really common mistake that we get in this unit, though, is I'll show you. If I rewrite 4, let's say I rewrote the numerator as 1 plus 3. Okay, that's equivalent to 4. And I'm going to rewrite the denominator as 1 plus 5. Okay, which is equivalent to 6. Can I cancel out these 1s? That would leave me with 3/5 if I did. Is that an equivalent fraction to 4/6 or 2/3? And no, right? They're very different fractions. So it's not allowed to cancel these 1s. Okay, this is a really common thing we'll see this unit. I would expect if I gave you this fraction with numbers, you probably wouldn't cancel the 1s. You'd know to add 1 and 3 and 1 and 5. You'd get 4, 6, and hopefully reduce. Okay. However, really commonly, if I give you the same exact expression, but instead of 1, I'm going to write x. So x plus 3 and x plus 5, where x could be 1. Can I cancel these x's? And this is the common mistake you're going to do a lot. Well, hopefully you won't do anymore. I cannot cancel these x's. Okay, there's always these like invisible parentheses around the numerator and denominator of a fraction. Okay, you're always supposed to simplify the top first, simplify the bottom, and then divide. So if I were to plug any number in for x, I need to add 3 first, then add 5, and then if there's a common factor between them, I could divide after that. Okay, but without knowing specific values of x, you cannot simplify this further. But what we can do, let's say if you started off with some expression like this, x squared over 9, let's do x squared plus 7x plus 12. Okay, let's say I was given this rational expression. Can I cancel these x squareds? And the answer is no. For the same reason I couldn't cancel these x's and that I can't cancel these 1s. If there's any addition or subtraction in the top and bottom separating terms, we cannot cancel things out unless we have an entire expression that matches between them. And we'll look at that. In fact, what I can do, though, to simplify this is we're going to factor these things out. Okay, up top we have that very common pattern, the difference of squares, which factors as x plus 3 and x minus 3. In the bottom we've got a quadratic. The factors of 12 that add up to 7 are 4 and 3, and I think they both need to be positive in this case. So x times 4 times x plus 3. And what we've done, just like we did with our 4, 6 back up here, is we've broken these into their factors, things that are held with multiplication. And if I happen to have a common factor now, which could be a common expression between the top and bottom, then and only then I can cancel stuff out. But that has to be factored for me to do that. So here, yes, I could cancel out my x plus 3 and my x plus 3. And my final answer would be x minus 3 over x plus 4. Now there's some restrictions here that we're going to talk about. Remember that the denominator cannot equal 0. So in that case, we'd have to exclude negative 4 from this factor. Negative 4 plus 4 would be 0. 0 times whatever this is 0. And even though this canceled out, you have to keep the domain of your original expression. So x cannot equal -3 from this as well. So somewhere you'd need to state x cannot equal -4 or -3. But this would be our simplified answer. Now the reason you'd want to simplify is this expression and this expression, the simplified one, give us the exact same values of x back for any x I plug in, as long as x isn't -4 or -3. So any value I plug in here, this is obviously or clearly much easier to plug numbers in and calculate than the original. So obviously easier to do by hand. It'd be very nice if this is like a computer program to make that easier as well. All right, so there's some steps that we're going to follow here. Okay, some steps to factor these expressions out. The first thing we're going to do is completely factor the top and bottom. So we need to break these things into their factors, just like we did here with 4 and 6. State any domain restrictions, any value that makes any of the factors in the bottom 0. Okay, so once it's factored out, it's easier to find those values. And then we're going to cancel out common factors between the top and bottom at a 1-to-1 ratio, meaning 1x plus 3 up top can only cancel 1x plus 3 down below, etc. So canceling it in a 1-to-1 ratio. Okay, so let's try some examples out here. Our first one, we're going to go a little nuts on. Generally, you won't have to break this down into the prime factors, but just to remind you everything that's going on here. Let's say I want the prime factors of 12. Okay. So we could do a factor tree. You could say 2 and 6, 2 and 3. But all my factors of 12, my prime factors, are 2 times 2 times 3. Okay. In the bottom, I'm going to break down 18. That's 9 times 2, and that 9 gives me a pair of 3s. So my prime factors of 18 are 2 times 3 times 3. Now, you won't always have to break this down. We're just going to overemphasize for a second here. The top, I've got n to the 5th and n squared. And I should have stated at the beginning that luckily there's no addition or subtraction going on here. Everything's held with multiplication, which is good. So we'll be able to kind of immediately cancel stuff out, common factors. Well, n to the 5th, remember that means n times n times n times 5 n's all being multiplied together. So n times n times n times n times n. Same thing in the bottom, n squared gives me 2 more n's. And now we've got all of our factors. This is like crazily factored out. Probably a little more than we'd usually need. Okay, before I cancel anything though, let's state any domain restrictions. What would make this factor equal 0? In that case, it's actually 0 itself. 0 times whatever this is, times 3 times 3 times 2, the whole bottom becomes 0. So from this factor, n cannot equal 0. From this factor, n cannot equal 0 again. And then our numbers won't change. So here we need to say somewhere n cannot equal 0, technically twice, but we only need to list it once. Okay, so now we can finally cancel out some common factors. We've got a common factor of 2 that reduces to 1 and goes away. Common factors of 3 and 2 pairs of n's that we can cancel out. So it leaves me within the top 2 times n to the 3rd power, 2n cubed, over 3. And even though those n's both canceled out in our reduced answer, we still have to keep this domain restriction of our original equation, our original expression. Okay, that wasn't too bad. So over here, we're going to do something similar. If they throw a negative sign in front of my fraction here, we're going to take that negative sign and kind of distribute it to everything in the top, which is really technically just one term there. So we're going to have negative 14 x to the 5th y to the 3rd over 42 x to the 4th y. Okay. So all I did was put the negative sign up top, basically. If there was multiple terms, different things held with addition or subtraction, you would have to distribute it to all of them. Okay, so here, once again, everything's held with multiplication. So we can go ahead and look for common factors to cancel out. Maybe instead of factoring it crazily out, we'll just look for things that we can reduce. So 14 and 42, 7 might be the obvious factor that they both share. But if you divide both by 7, negative 14 divided by 7 is negative 2. 42 divided by 7 is 6. I might notice that I can reduce my other fraction further. So let's divide out 2 was also a common factor. And so my numbers end up reducing all the way down to negative 1/3. So because both 7 and 2 were common factors, that meant 14 was actually the largest number we could divide out of both. Okay, actually, once again, before we cancel these out, let's state our domain restrictions. Remember that I just have 4 x's down here, just like we had those 2 n's. And from that, x cannot equal 0 4 times, but we're just going to write it once. X cannot equal 0. And we also have a second variable down here this time. Y cannot equal 0. And again, I'm just worried about the denominator, not the numerator. Okay, so there's our domain restrictions. And let's cancel some stuff out. We've already canceled out some numbers. I have 5 x's up top and 4 down below. So we can cancel out 4 sets of x's, which cancels all of them in the bottom and will leave me with just 1 up top, x to the first, or x. We have 3 y's being multiplied up top and 1 down below, which means we can cancel 1 set out, which cancels the only one in the bottom and leaves me with 2 up top. So end up with negative 1xy squared over 3, or negative xy. You don't necessarily need the 1, as long as x and y do not equal 0. Okay, let's try another one. Number 3, now you've noticed we do finally have some addition or subtraction. To go around this, we need to do what we talked about earlier, factor. I need to break things into factors. And one of the things you always look for when you hear the word factor first is a greatest common factor. So if you look at the top, number-wise, they both have a 9 in common. They're both divisible by 9 as the largest number, and they both have an a. So we're going to divide out 9 and an a from the top. So 9a squared divided by 9a. The 9's reduced to 1, and a squared over a is a. 45a divided by 9a. 45 divided by 9 is 5, positive 5. And a divided by a would cancel. Okay. Now if you always want to be sure, think of redistributing this. That would give me 9a squared plus 45a. Okay, in the bottom, there's nothing we can factor out here, but I can think of a plus 5 as its own expression, its own factor. Okay, so now I've got everything held with multiplication. 9 times a plus 5 over a plus 5. So what value would make the denominator here 0? In this case, it's negative 5. So there's my restricted value. So now I can look for common factors. I've got an a plus 5 that matches in the top and bottom, and I end up with 9a over 1, or 9a is my reduced expression, as long as a does not equal 5. And obviously, this is a much easier function to plug into than that if I needed to crunch some numbers. Okay, let's try one more over here, number 4. We've got a full quadratic up top, so we're going to look to factor that out. So I need factors of 72 that add up to negative 17, which end up being negative 9 and negative 8. So this quadratic up top factors as x minus 9 times x minus 8. In the bottom, we have a common factor. 5 divides both of them nicely, and they each have an x. So we're going to take out a 5 and an x. 5x squared divided by 5x gives me x. The 5's cancel to 1, and we cancel 1x out. Negative 45x divided by 5x. Well, negative 45 divided by 5 is negative 9, and the x divided by x cancel. Okay, so we've got everything broken into factors. The values that I can't have in the denominator, in this case, are positive 9. X cannot equal 9. And even though we're used to pairing up that 5 with the x, it's really just x is its own factor here. This x can't be 0, because 5 times 0 times this would be 0. Okay, so remember, we're really setting every factor equal to 0, anything that has a variable. And then solving those equations. Like, when does x minus 9 equal 0? When x is 9. When does x equal 0? When it's 0. All right, we stated our restrictions. Simplifying here, we have an x minus 9 between the top and bottom, and I get x minus 8 over 5x. Be careful not to try to reduce further. These x's do not cancel because we have addition or subtraction present. I can't go any further. All right, now we've got some more. Up top here, again, I've got addition or subtraction, so we're going to need to factor these out. You might notice we have a difference of squares, n plus 4 times n minus 4. And at the bottom, we have a greatest common factor. They're both divisible by 6, and they each have at least one n. So we're going to divide each by 6n, which leaves me with n minus 4. Okay, remember the denominator, if there's a variable down here, cannot equal 0. So the values we need to exclude are positive 4 from this factor and 0 from this n. Okay, so there's my restrictions. N cannot equal 4 or 0. I notice we have a common factor of n minus 4 we can cancel. And I end up with n plus 4 over 6n. Okay. Remember, again, I cannot cancel those n's out. There's addition or subtraction here. Number 6, we've got a couple quadratics. For the top, the factors of positive 16 that add up to negative 10 are negative 8 and negative 2. So the top quadratic factors is b minus 8 times b minus 2. Okay, our bottom quadratic, factors of positive 24 that add up to negative 11 are negative 8 and negative 3. So b minus 8, b minus 3. Okay, now that it's factored out, the values we can't have in the denominator are positive 8 and positive 3. So b cannot equal 8 and 3. And I notice we do have a common factor, so we could reduce. Canceling out those b's, we get b minus 2 over b minus 3. And that's it. Do not cancel those b's out. Remember, there's addition or subtraction. That is not equivalent to the original. For number 7, we have a quadratic up top, no greatest common factor. But this 2 in front makes it a little more complicated. So whatever method you learned to factor when a is not 1, in this form ax squared minus bx plus c, if a is not 1, we learned bottoms up in my class, so we're going to do bottoms up here. And we do that by kind of hiding the a over here. X squared minus 5x minus 50. We multiply it over. Okay, and we're going to factor that quadratic. Okay, it's not equivalent to our original. We're kind of cheating right now, but we're gonna undo it and find the correct factors in the end. So the factors of negative 50 that add up to negative 5 are negative 10 and positive 5. Okay, so the factors of this kind of cheated quadratic are x minus 10 and x plus 5. And here's where we undo our cheat. All we need to do is divide each of these numbers by the 2 we cheated with to start with. So we divide each by 2. If it reduces to a whole number, there's one of my factors. X minus 5 is one of my factors. If you get a fraction, you have to reduce it as much as possible, but this is as reduced as possible. And if there's still a denominator, you bring it up in front of x, hence the name bottoms up. So we end up with 2x plus 5. So these are the factors of that quadratic up top. Down below we have 9 as a common factor. It divides both 9 and 45. And dividing each by 9, we get 1x minus 5. All right, and now that it's factored out, let's state any excluded values. The value of x that makes the bottom 0 is 5. So we have to say x cannot equal 5. And we do end up having a common factor of x minus 5. So we get 2x plus 5 over 9. All right, one last example here. I know we're going a little long. Let's factor this quadratic up top. There's no greatest common factor, but I need 2 numbers that multiply to positive 18 and add up to negative 11, which are negative 9 and negative 2. So k minus 9, k minus 2. In the bottom, 8 is a common number that divides both. So dividing an 8 out of both, we get 1k minus 9. And now that we have all of our factors, we can find the value of k that makes the bottom 0, which I can see here is going to be positive 9. So k cannot equal 9. Canceling our common factor of k minus 9, we end up with k minus 2 over 8. So quick check, can I simplify the 2 8s here? The answer is no. Be careful. Do not. There's addition or subtraction in the top. I cannot do this. I need to take whatever value of k, subtract 2 first, and then divide by 8. And that does not necessarily reduce. Right, imagine if k was 3. 3 minus 2 is 1. 1 over 8 doesn't reduce, so I cannot reduce. So it's really dependent on if it ever reduces whatever value of k, and we don't know that yet. Okay, so this is how you simplify rational expressions. We need to break them into their factors. That's really important, like we talked about at the beginning. Just like we broke down that 4, 6 into its factors. We need to break things into its factors. We need to state any restricted values, like we had over here. And then we can simplify. Okay, but don't cancel anything out if there's addition or subtraction present. Factor it and look for common factors.